Welcome to a tutorial of Proflan YouTube channel. In this particular video, we're going to discuss IAL Unit 3 Physics. This is a master class that will enable you to understand how you are supposed to answer each of the question that is set in such kind of paper. So as you are preparing for your exam, you'll be in a position to work it out. So we are going to look at this paper of May-June 2023, which is going to base a foundation of our analysis today, whereby we're going to discuss which kind of questions really get tested in that paper and how, and which is the best practice which can be able to earn you the best mark. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do further tutorials, you'll be notified. So we're going to look at this question here, whereby we're told in question 1, the examiner was testing whether you understand how to answer question to do measurement with a micrometer screw gauge. And in this case, what you need to understand is that a micrometer screw gauge, you need to read the slip scale, and also you need to read the slip scale, and then you read the main scale, the thimble scale. You need to read the slip scale and the thimble scale, then you add the two together. So you can be able to see at this given point we have this scale here, this 0, then 1, but when you have this particular mark at this given point, this means 0.5. So this 0, 1, 1.5. So that's why you can see I was able to record 1.50, then plus this thimble scale. You are going to check which is the mark that is coinciding with this scale and the thimble scale. So you see I placed a dot here that for this scale this is the mark that you need to read, and for this scale this is the mark you need to read because it's coinciding. Then which means this is going to be 20, 21, 22. So this scale here reads to two decimal places, so we are going to say 0.22. then when you add the two together, you are going to get 1.72 millimeters. That is how you take a reading from a micrometer screw gauge. And something that you need to understand, usually this kind of apparatus, they have 0 errors. So you can be able to correct this measurement by either adding the 0 error or subtracting the 0 error, depending on the type of 0 error that is there. So if you are having a negative 0 error, you are going to add that error to this reading that we're having here. But if you are having a positive 0 error, in this case, you are going to subtract in that case. So it depends how a question is set. But for accuracy, you have to correct that error. The next question that you are going to be seeing in most of this exam is the question of uncertainty. You will never miss a question on uncertainty, and you'll be given two types of question for uncertainty. One where you have a single value. For instance, here we have read 1.72. That is a single value uncertainty. So in such kind of scenario, what you do is to work out uncertainty, and uncertainty is a half of the resolution. Usually resolution is the least unit of a measurement. In this case, since this is in two decimal places, the resolution is 0.01. so if you take that 0.01 divide by 2, you are going to get the uncertainty of this particular apparatus. Once you have that, then uncertainty now becomes 0.05, which is the uncertainty rather. Then percentage uncertainty will be the uncertainty that you have gotten here divided by the reading that we had gotten, 1.72 times 100, and that translates to 0.29 as the percentage uncertainty. Another question that will be there is whereby you are given different readings, and then you are supposed to work out the mean. Then from the mean you can be able to work out the uncertainty. So that question also will be there, but we are going to see it later. Now we are told explain how she should reduce the source of error in this measurement of t. We know that this instrument probably have 0 errors, so need to check the 0 error and reduce this 0 error by either adding or subtracting, and this usually reduce the systematic error. But also we have another type of error which is called random errors, which could be as a result of wrong readings. So but 0 errors introduce systematic errors. Describe the way to the student balance the rule on the pivot as shown, recorded the and recorded the position of the center of gravity of the ruler, and then we are told to describe the method to determine the mass of this meter rule. So the way to do this is to use principle of moments, and we know that clockwise moment is equal to anti-clockwise moment. So if we have the mass of 20 grams, if it's attached to one end of that meter rule or meter ruler, then it means we can be able to support it or to pivot it at a given point if we know the distance from the pivot to the mass of 20, and also we know the distance from the pivot to where the center of gravity of this ruler is. Then we can be able to apply the principle of moments in order to work it out. So you can see, if we say clockwise moment equal to anti-clockwise moment, we can say m times x is equal to d times 20, and making m the subject of the formula will be able to get the mass of this particular ruler like that. So that's how you are able to determine the mass. And basically this is a paper that is testing practical skills that you learned when you are doing unit 1 and unit 2. In this case, also in question 2, we are told a student investigate the properties of a solar cell. This is the question that really gives most of the student trouble, because this is unfamiliar kind of setup that was brought in this year of 2023. Explain the purpose of the convex lens, and the purpose of the convex lens was supposed to concentrate the rays to the solar cell so that the intensity of light can be increased. And how to do that? Because you see the lens is placed within the tube, so within the cylinder. So if there is a ray that passing that, it will go straight there. If there is a ray going this way, it will be directed like that. Then so basically rays will be directed to the solar cell, and that's going to increase the intensity. Describe how 2 more ways to keep the light intensity incident to the solar cell, and I highlighted 2 points: keeping the solar cell at the same distance from the filament lamp, and also keeping the solar cell at the same angle to the filament lamp, so that most of the light is going to be incident. We have part B, whereby we were supposed to add an ammeter and a voltmeter in that setup. Remember, a voltmeter is usually added parallel to the component, and ammeter is added such that it's in series with the rest of the component of a circuit. So that's the concept that was being tested at that given point. Suggest the reason for using a fixed resistor. We are having a fixed resistor here, and the fixed resistor, when you are asked such kind of a question when it comes to unit 3, it's meant to limit the maximum amount of current that can flow in the circuit. So that is basically the reason you're gonna give if they give you a question like that, to limit the maximum current that flows in the solar cell. Describe 2 advantages of using solar cell to power a small water pump in a garden. Here we were just I think this is a kind of more of a IGCSE question that they brought here, because we talked about renewable resources and non-renewable resources. So basically that's what they were testing at this point. The solar cell do not emit greenhouse, so it does not contribute to global warming, and also it's a renewable energy resource, so it can be used forever. So I don't think there's any candidate really could have a challenge to do that. A student investigated the diffraction of electrons using electron beam as shown here, and the potential difference V accelerate electrons from the hot filament towards the graphite foil. The electron diffracts as they pass through the foil, producing ring pattern curve fluorescent screen as shown there. And basically, if we are doing also unit 2, this was to demonstrate the wave nature of electrons. Yeah, so the student used the vernier calipers to measure the diameter of the rings on the curved screen. Give 2 reasons why the vernier calipers are more appropriate for this measurement than the transparent ruler. Remember, a vernier calipers has a lower uncertainty. Yeah, has a lower uncertainty because it has a smaller resolution. A vernier calipers usually measure to 2 decimal places, so the resolution, the least unit is 0.01 centimeters. Yeah, so you can see it has a lower resolution, but for a meter rule it has 0.1 centimeters. So you can see this one has a larger uncertainty compared to the vernier calipers, which has 0.01. so basically a small resolution, hence has low uncertainty, and can also measure without parallax error. So whenever you are taking a measurement using a meter rule, chances are that you are likely to make a mistake, you are likely to read wrongly by positioning your eyes wrongly. So basically that is why we are saying here that this could result to error of parallax. Moving to Roman 3, we are supposed to describe how the student could measure the diameter of the ring accurately, and this particular point, remember, the student has used a vernier calipers. So the next thing that the student is going to do is to ensure that is checking the zero error. Once he has checked the zero error, then the student is likely to correct that error, and that is going to make the measurement a bit more accurate. At the same time, this particular student needs to take measurement in different orientation, and then now we will have multiple values of the measurement, then he can be able to make find the mean, and that will reduce any random error that could be there. So we need to move to part B. We are told the student used the diameter of the ring to determine the wavelength lambda of the electrons. He repeated this for 2 more values of V, and the student also determined the value of a constant using the formula acceleration is equals to V, which is what? Kilovolts, yeah, and in kilovolts, lambda squared. We are supposed to determine the mean value of acceleration A, and basically this is the particular question I was really talking about. I was saying that every time you are going to do Unit 3 paper, you'll have 2 questions on uncertainty in the paper. One whereby you have a single value, and another one where you have multiple values. Then you are expected to work out the mean, and then use the mean in order to work out the uncertainty. And basically that's what we are having in this case here, because we are told to work out the mean of A, and to find the mean, that is the average. Of course, you need to add all the values, divide by the number of values that you are having. Then once you have gotten that, also you need to work out the uncertainty. How do you get the uncertainty in this case? When you have multiple values, you take the largest minus the smallest. When you subtract them, you are going to get what we call the range. And the range now, if you do a half of the range, that now gives you the uncertainty in this particular case. And basically that's what I've basically done here, so that I can be able to get the mean. I got my mean as 1.22 times 10 raised to the power negative 18, and uncertainty will be the difference. What I did, I subtracted 1.32 and 1.11 so that I can be able to get the range, and that value I got as 0.01 0.21, I divided by 2 because 0.21 is the range. I divided it by 2 so that I get the uncertainty. So if you work out the uncertainty, you'll get the value equivalent to 8.6% as our uncertainty. Up to that particular point, we have covered the two particular questions on uncertainty that will be tested, and you will find that most of these exams, the questions will remain be the same, but you'll be given different case scenarios of the practical setup. If you are new to Proflan YouTube channel, consider subscribing so that in time I'm going to do more tutorials, you'll be notified. So we are going to move to the next part here, whereby we are told, give 2 reasons why this is a better method. What is the better method that we were talking about? Where the student repeated the investigation for different 6 values and then used those values to plot a graph. So if you are plotting a graph, remember when you are plotting a graph, you are going to use more data values. And if you are using more data values, their chances are that you are going to be more accurate. And also when you are going to draw the line of best fit, it's like you are performing another average, and from the line of best fit you can be able to identify anomalous points, and then you exclude it, and that is going to enhance the accuracy of your experiment. Then we are told that A can also be calculated using this particular formula, and then you are given values where you are supposed to substitute in order to find the value of H. So basically I try to make H the subject of the formula here so that I substituted the value that were provided in order to get 6.52 times 10 raised to the power -4 joules per second. The percentage uncertainty in calculated value is 6%. Comment on the accuracy of the calculated value. So because H is Planck's constant, H is Planck's constant here, and we know that is 6.63, then what we were supposed to do is to work out the upper limit of the calculated value, and the upper limit is 6.92, and you can see now the value that I've gotten here is above 6.63 times 10 raised to the power -34 joules. So which means that the Planck's value that we usually know is between the lower limit and the upper limit of the calculated value, and this is now going to form a basis of us concluding that the calculated value is accurate. All right, moving to question 4, which is the last question. And remember, every time you are going to have a practical question, you are going to have a practical paper, chances are you must have also a question that is really analyzing the ability to draw graphs. So that's why now in this particular question that we are having here is a question that is going to test that skills of drawing graphs and also analyzing the graphs to find different quantities, as we are going to see. Now here we are told a student investigated the extension of an elastic cord. She hung 1.2 kg mass from the elastic cord as shown there. Identify health safety issues and how it may be dealt with. Anytime you are going to have Unit 3 paper, you must have a question that enables you or test the ability for you to be able to identify hazards or health issues as far as that experiment is concerned, and how you can be able to solve their problems. So in this case, you need to analyze, you need to analyze the apparatus that are there and see which danger can they pose to the person who's going to do that experiment. So if we can look at this, we are having an elastic cord. So chances are this elastic cord can snap and hit your eye, can snap and hit your body. So in that case, we need to protect ourselves against that, so we can be able to put on protective goggles. And also we have a 1.2 kg mass. Imagine that mass breaking from there and falling on your feet. Then it means that's an health measure that we really need to take place, because you need to do what? put on safety boots so that you can be able to protect yourself and your feet from being hit by that mass. Also, we can talk of the two stands that we are having here toppling, because if we are having the look at the way the base was positioned, they were positioned the opposite side, so the likelihood of this mass being heavy and pulling these stands so that they can be able to topple. If they topple, the setup is spoiled. So the thing we can do, we can bring the aspect of G clamp. We can fasten these using a G clamp in order to fasten to ensure that it's a bit more stable. Let's talk of identifying two sources of uncertainty and errors in this experiment. Remember, whenever you are measuring the angle between here, it will also be a bit difficult because there will be introduction of error of parallax in the process of measuring that angle. So we can talk of parallax error when using a meter rule to measure the distance x, because you see there will be some measurement of some distance x here. So in the process of taking the measurement, there could be error of parallax. Also measuring the angle will be error of parallax resulting there. Suggest the modification to reduce the effect is to ensure viewing the measurement perpendicularly when we are taking the measurement, and also you can be able to take multiple measurements so that you can be able to find the average of those values. Yeah, so basically that is it. And then we are told explain why the graph of this, explain why the graph can be used to determine the value of G. So you can see here we are going to plot a graph of theta over 2 against 1 over x. So we can be able to use this formula here in order to find G, and this is the approach we're going to use. If you are plotting the graph, then the equation connecting the quantities cos theta over 2 is equal to mgk 1 over change in x. Now, since there is no variable here, it means it's going to pass through the origin. So we are going to talk of a straight line passing through the origin. So if you compare and relate this equation with the equation of a straight line y equals to mx plus c, it goes without saying that this particular value that we have here, mg over k, because this is the value that is plotted on the x-axis, then it goes without saying that these quantities represent the gradient. So if you take this quantity mg over k and equate to the gradient of this line, which we can be able to work out of change in y over change in x, then we can be able to rearrange and make G the subject of the formula and say now therefore G is going to be k times the gradient divided by m, and that is how we can be able to use that. Whenever you are also given a table in this exam, ensure you are going to record your calculated value in the same number of significant figures as the raw data. So that is exactly what I did. And don't forget to include the units, because if we are finding 1 over change in x is going to be m raised to power negative 1 in order to do that. Another area is to ensure that you draw the graph using the correct scale and label the axes with the correct quantities and the units that are required there, so that you can be able to earn all the marks. So the next question that we are being asked here is to determine the gradient, of which you use change in y over change in x. Then you can be able to select points in your graph and ensure you use the points which are a bit apart, so that you use almost a half of your graph in order to find the gradient. And if we work out our gradient, we are going to get our answer equivalent to what? 0.078. And something that we need also to ensure whenever you have worked out this kind of question gradient, ensure you include the units of that gradient, because you are talking about quantities. Also, that gradient probably will be having some units, and in that case we need to include the units there in order to earn all the marks. Lastly, determine the value of G, because we mentioned from the previous section that G is going to be gradient times the value of K, and then divide by the mass. And in this case, you can see they have given us the mass and they have given us the value of K. So possibly our work was there to just substitute in, and upon substituting we were to get 9.43 meter per second square, which is basically the acceleration in this case. And if you are new to Proflan YouTube channel, consider subscribing, and also you can be able to check more videos I've done in Unit 3. Check in the description, you'll have a series of other videos I've done, so that you can be able to see how this question you really usually get asked in each and every year. You will find that they are really very similar questions, but really tweaked to fit a particular context of an experiment that is given. I believe you got value from this particular channel, and if that's the case, you can also share this video to your friends, encourage them to subscribe. See you, and the best of luck in your upcoming exam.